Let's learn about operations with radical expressions. In this Peanut comic, Peppermint Patty says, "You're lucky. Do you know that, bird? You're lucky because you don't have to study math. You don't have to know about rationalizing denominators and dumb things like that. You're really lucky." And then Woodstock's off to rationalize the denominator. On our agenda, we're going to talk about some radical vocabulary. We'll look at the buttons for radicals on our calculator, simplify, talk about when and how we can add and subtract radicals, multiply, and then divide is just rationalizing the denominator. Let's get ready. You're going to need your notes, pencil, calculator. We're going to work through a lot of short problems. Here's our radical vocabulary. This little number tucked inside sort of the check mark of the bar is called the index. If there is no number there, it's an assumed 2. So we don't usually write the 2, but we're going to be seeing indices of 3 and 4, etc. So you want to make sure that's tucked in there for the index. The bar itself is called the radical symbol, and then the number underneath is the radicand. Switching from radicals to roots, make sure you're being careful with the plus minus signs. Don't just assume that the square root of 25 is going to be positive and negative 25. That square root is already there, so it really just means the positive root. So the answer here is 5. If you were, say, completing the square and you took the square root, so you were drawing in that square root radical, then you would have to remember the plus or minus. In example 2, we're looking at the cube root of 8. So we're trying to think about what number times itself 3 times is going to equal 8, and that's going to be 2. And then we have negative cube root of 8, which is going to be negative 2, because negative 2 times negative 2 times negative 2 is going to be, well, it's going to be 2 and then made negative. And I should have written it like this too, because we're allowed to do that, and that would be negative 2 also. Radicals on the calculator. You should be familiar with the square root button. You're going to hit the second and then the x squared, and that will allow you to have the radical. For higher roots, you want to press math and then go down to number 4. That will give you the cube root, and math and down to number 5 will give you any root, but you do have to hit the number first. So if you wanted the 4th root, you'd have to hit 4, then math, then down to number 5, which would then give you the cube root. When we're simplifying, keep in mind that you can separate multiplication and division into factors to allow you to simplify. So here we have a cube root of 16, and 16 is not a perfect cube, but I know that its factor of 8 is. So I can separate this into the cube root of 8 times the cube root of 2. I can take the cube root of 8 and I get 2 cube roots of 2. Be careful, you may want to add some parentheses. You don't want it to look like 2 cubed and then the square root of 8. So make sure you're tucking that 3 into the radical bar. If I have the square root of a fraction, I don't want you to pick up your calculator and tell me the decimal answer. You can, if you have a big square root, you can separate that into 2 little square roots, and we get the square root of 25 over the square root of 16, which is 5/4. You can only add or subtract when you have the same radicands. If not, then you should try to simplify. So in exercise 6, I have 3 root 5. So root 5 is my group and 4 root 5. So those groups are the same thing. So really I have 3 of them and 4 of them. So I have 7 of them, and that becomes 7 root 5. Notice I did not change my grouping. I did not change my radical. In example 7, my radicands are different, so I'm going to simplify them. And I like to write the perfect square first. So I have 4 times root 9 times root 2 minus 2 root 25 root 2. And then I can simplify. So 4 times 3 is 12 root 2, and 2 times 5 is 10 root 2. And now they have the same radicand, so I can combine them for 2 root 2. I would like you to pause and try this example. You can see that my radicands are not the same, so I'm going to simplify. 48 is 16 times 3. 32 is 16 times 2. And 27 is a 9 and a 3. So then I have 6 times 16, so a square root of 16, which is 4. So 24 root 3. Plus 12 root 2 minus 12 root 3. So I do still have some different radicands. That's as far as I can can go with as far as simplifying. So I can combine like terms with my radical 3. So I'm going to have 12 root 3 plus 12 root 2 for my final answer. You can't put those together at all. Simplifying with variables. So the index, this little 3, is going to tell me how many things are in my group that I can then take out. So if I break this down, so I have the cube root, and 27 is 3 times 3 times 3. I can see I have a group of 3. And then I have 6 x's. And if I break those up into groups of 3, I have 2 of them. So everything can come out. Nothing will be left behind under my radical bar. And I have 3x squared that this simplifies to. With division, again, I have the big radical bar, so it's the same as 2 little bars. I can simplify my numerator to x. My denominator becomes the cube root of 7, which we don't want to have that radical in the denominator. So if I have a radical in my denominator, I want to rationalize it. So I'm going to multiply it by 3 root 7, top and bottom, because remember, I'm allowed to do that. That's just 1. So I get x times the cube root of 7 over the cube root of 49. Well, that didn't do it. I still have a radical in the denominator. So what I really need to do is I need to multiply it by 1 more cube root of 7. Because then that's really going to be in the denominator 3. So 3, the cube root of 7 cubed. So my denominator then will be 7. So with square roots, we can just multiply it once. But with cube roots, we need to multiply it twice. Then my numerator becomes x cube roots of 49 for my final answer. No radical in the denominator. Go ahead and pause it and try these. In my first example, the 4th root of 16 is 2, and the 4th root of x squared is x. In example 12, the 4th root of x to the 8, well, there's 2 groups there, so I have x squared, and then I have the 4th root of 3. I have a 4th root, which means I need to multiply it by 3 more of those. So I'm going to do the 4th root of 3 over the 4th root of 3 cubed. So my numerator is a little ugly. It's x squared times the 4th root of 27. I definitely want parentheses there so my exponent doesn't become a 24. And then that's all over 3. And for example 13, I talked about how you can pull them apart into your factors, but you can also multiply. You don't have to have the same radicands. So as long as you have the same index, you can multiply, and I'm going to get 3, the cube root of x to the 9, and then that's going to be x cubed. Let's look at multiplying with radicals. And here I have 2 binomials. So I'm going to do the big distributive property, watching my signs. I'm going to get negative 5 minus 3 root 12. And then negative 10 root 3 minus 6 root 36. I have more simplifying to do. I need to simplify the 12, simplify the square root of 36. So we get negative 5. Square root of 12 is 4 and 3. So that becomes negative 6 root 3 minus 10 root 3 minus 36. I can combine my integers and my radicals. So I get negative 41 minus 16 root 3 for my final simplified multiplied answer. With dividing with radicals, I want you to take a look at both of these examples. They're a little bit different, which means my strategy is going to be a little bit different. In example 15, I've got this extra minus 1. So the whole thing is not a radical, but in 16, the whole thing is a radical. So if I were to just multiply this by the square root of 5, it's not going to be helpful because I'll end up with 5 minus root 5, and I still have a radical down there. So we need to use the complex conjugate. So we're going to change the sign of that 1 and add it, make it plus 1. Top and bottom, square root of 5 plus 1. I'm going to distribute it in the numerator, 2 root 5 plus 2. Distribute it in the denominator, and I get 5 minus root 5, no, plus root 5, minus root 5 minus 1. So my numerator stays as 2 root 5 plus 2. My middle terms cross off, so I get 4. I should continue to simplify that, so I get root 5 plus 1 all over 2 for my simplified answer without a radical in the denominator. For example 16, again, the whole thing is squared, so I can just get away with multiplying by that. Please, please, please don't try to simplify the denominator and say it's x minus 1 because those are both perfect squares. It doesn't work that way. It's not going to help if you factor it. Just keep it as the square root and multiply. When I multiply my numerator, I've got a distributive property. So I've got x times the square root of x squared minus 1 plus 3 times the square root of x squared minus 1 all over just the inside x squared minus 1. It's not pretty, but that's our big simplified answer. So to recap, make sure you're always simplifying your radicals. Pay attention to your positive and negative signs. When you add and subtract, you need like radicands. Never leave a radical in the denominator. Make sure you're rationalizing it. And now look at this Van sign. Is it the shoe or is it actually the square root of the answer? Good job.